Now we'll solve some gate problems related to subnetting. Okay. So first question, which is asked in GATE 2007, the address of class B host to be split into subnets with a 6-bit subnet number. What is the maximum number of hosts in each subnet? Okay. So here the question is, you have a class B network. We have to split it into, some subnets with a 6-bit subnet number. You can understand that we have to borrow 6 bits from, host part. That is what the idea. Then what is the maximum number of hosts in each subnet? First of all, we'll see what is how class B pattern looks like. In a class B, usually there is a, network part of 2 octets and host part of 2 octets, right? 8, 8, 8, 8. This is network, this is host. If there is no condition of subnetting, nothing, then the number of hosts in this one is 2 to the power of 16 minus 2. You know that already, correct? Because there are 16 bits for host part, then the number of hosts this network supports is 2 to the power of 16 out of 2 to be removed. Why? All zeros in the host part is network ID, all the ones is broadcast address, remember it. But what we are doing is now we are subnetting it. That means this network is now divided into subnets with how many bits? 6 bits. So we will be, wherever you borrow doesn't matter, but from host part we have to borrow. Assume that we are borrowing 6 bits like this, 1, 2, 3, 4, 5, 6. Then the question, how many remaining bits you will have for each subnet? That means 6 bits if you use for subnet number, then the remaining bits, if you see here, remaining 2 bits, okay, and here 8 bits. Total 10 bits we can use for host, right? That means each subnet will have remaining 10 bits for the host. Then how many hosts such subnets can support? Each subnet can support 2 to the power of 10 hosts, out of them 2 to be removed, correct? 2 port and 1024 patterns minus 2, 1022 patterns can be used. So finally each such subnet can only support 1022 hosts. Okay, that is one thing. Then how many subnets you can have? You are using 6 bits for subnetting, right? Then how many subnets we can form? By changing these bits, differently, we can have so many subnets. Since you are using 6 bits. Example, if you use only 1 bit for subnetting, then if I use 0 here, 1 subnet. If I write 1 here, another subnet, isn't it? But you are using 6 bits, then 2 to the power of 6 ways you can change them. So 2 power 6 is nothing but 64. So we can have 64 subnets by changing that 6 bits. Each subnet can have 1022 hosts. So answer is this one, option D, I think. 64 subnets we can form, and each subnet can have 1022 hosts. Understand? So it's very straightforward question. Now we'll see one more gate question which is asked in 2015. Consider the following routing table at an IP router. Network number is given, net mask is given. See, this is subnet mask and next hop. Okay. So we have to identify each and every network's interface, next hop otherwise. So take every ID and with net mask. If it matches with network number, then send through that interface. That is the idea, right? But only one thing you should remember, if a network address matches with multiple net masks, then we have to take a net mask which has longest prefix, otherwise longest number of ones. We will see that. So here 128.96.171.92, I have written it here in a binary format. So why 128 is not expanded? Because you see the net masks, we have 255, 255. Then simplification is easy. Anything dot 255 is that thing, right? Similarly, that's why first octet, second octet, everywhere in net mask is 255. That's why I did not extend. So it is easy to say. Now similarly, last octet, if you see all zeros, that's why anything dot 0 is 0. So simplification is easy. For that I don't require binary pattern. But here this 254 and something, so it depends on the pattern. That's why for third octet I have expanded, you see, everywhere. Now what I did is I took all the IP addresses and I have written in this expanded form, I can say, otherwise simplified form. So this is address number 1, this is address 2, this is address 3, this is address 4. Now this is your first subnet mask. In the table you have only 2 net masks. So net mask 1, net mask 2. 254 means what? Other than the last bit, everything should be 1. 252 is nothing but this one. Now, so this is 255, need not to expand, same reason. Let's begin. Now what we do is, the process is very simple. Take the first IP address, apply, and with this one. First of all, check. If it matches, then you have to check this one also. Remember one thing. Example, let's say this IP address, if you, and with this one, if the result is success, that means if you get the corresponding network number, then this IP address belongs to that network number. But sometimes what happens, this IP address, if you AND with another subnet mask, still it may match. When an IP address matches with multiple net masks, what we do? We take, longest number of ones, right? So here, that's why already this, first mask has longest number of ones if you compare with this one. So that's why what I do is, once you do AND with this IP address and the subnet mask, then if it is successful, you don't require to check this one. Because if though it is successful next time also, we don't consider, because longest ones are having in this one, right? That is the idea. So let me begin with that. Let's take 128.96. I am writing the answer here. 128.255, 128. 96.255, 96. That's why I did not expand it. Now you see, you have ones here, right? 7 ones. 1.1, 1. 1.0, 0. So you get same thing up to 7. Whatever you have, same thing will come back. 10, 10, 10, 1. Now this last bit is 1 here, 0, 1.0, 0. And 92.0, 0. Now we'll understand it. 128.96.10101010, which is nothing but 1 less than. In the previous address you have 1, here you don't have 1. So automatically I can say that what was your address? 171, right? This one 171. This will be 170. 1 less than that. So 128.96.170.0. Now look into the table. Yes, it is matching. Then you don't really require to check with another mask, right? And one more thing you remember. If this matches with this IP address matches with this one, it can't match with, if you do the same way, same answer you get. Sir, why are you not doing for this one? This mask, this mask, this mask, same, right? If you apply here, same answer you get. What you get? 128.96.170.0. Definitely, these two cannot be matched, right? So, this is the perfect match. But there is a danger that if you apply, and with this one and this one, you might get this address. Let's try so that you understand. So, finally, at this moment, this interface 0 is matching. Okay, that means this first entry is matching. Second one we'll see. We do AND with 252, which this one. So 128.258, 255, 128.96.255, 96 dot. So if you see 1 1, yes 1. See 1 2 3 4 5 6, 6 ones are there in this net mask, right? Then here the first 6 bits whatever you have, you copy them, because same thing you get. 1.1 1, 0.1 0. 1.1 1 in that way. So 0.1 0, 1.1 1, 0.1 0. That's why blindly copy them. These 2 bits we have to see carefully. 1.0 0, 1.0 0. You get like this. Dot 92.0 0. So what is this? 128 plus this one 32. 128 plus 32 160. 160 plus 8 168. Correct? So 168, is it matching here? No, it's 164. So directly I can say that only in this, so first row matches, remember it. Okay, so that's why only one in first interface maps, right? So 1 maps with A. 1 means this IP address 1 means interface 0. Same way we will do for second IP address. 128.96.167, this one dot 151. So first of all we do AND with first subnet mask, this 255 thing. So 128.255, 128. 96.255, 96. Now here starts. You have, I'm ANDing with this first mask. Okay, you have 6 ones. So in the first 6 positions, whatever you have, it will come back 1 0 1 0 0 1 1. Then last bit 1.0 0 dot 151.0 0. Now what is this one? 1 less than your original one. So it will be definitely 166. You can check. 128 plus, this one is 32. 160. 160 plus this one is 6, right? 4 plus 2 6. 166. So 128.96.160.0, yeah, here it matches, correct? So that means, remember, so one possibility is R2, but let's try with 252 also. That means second subnet mask, second different subnet mask. If you try second different subnet mask, you get 128.96.255.96. See, 1.11. So here there are 6 ones. So first 6 positions are straightforward. You have to copy them, 101001. Then last 2 bits, right here, 00 dot 151.00. Then this will be 128 plus 32, 160, 160 plus this one 4, 164. Yes, it matches. So 128.96.164.0, it's matching here also. Okay, so what I want to say is, whenever there are two matching entries, we should be clever. We have to go with longest prefix, otherwise maximum number of ones. This subnet mask has maximum number of ones, that's why it will go with R2, remember it. So second one is R2, I write here. Okay, so here it is interface 0, interface 0 R2. Now in the same way we will do for third one. Nothing is there, it's very easy. 128.96. This is 163.151. First of all, and with first subnet mask or net mask. 128.250, we are using this one, 128.255, 128.96.255.96. Now there are 6 ones, copy them, 1010001. This 1.00.151.00, it would be direct, it's straightforward, it's 160, correct? Sorry, it is 160 plus 2, 162. So 128.96.162.0, do you have such entry? No, correct? So this is wrong mapping, that means, so this will not match. Let's try this one. So 128, second one I am trying, 128.255, 128, 96 and 255, 96. Now here 6 ones, right? Copy 6 ones. Sorry, 6 positions, 1 0 1 0 0 0. These 2 positions we have to try, 1.00, 1.00 dot 151.00. So it would be 128 plus 32, 160. You have any entry for 160? No. That means there is no mapping, right? Really, if you add this with this, you have to get 160, but you did not get it. That means what? So there is no proper entry. For that we have default. So we have to send through default. That means this is going to R4. Remember it. Next, 128.96.164.121. Last one, this one. Again same story. Mechanical process, right? Let's try. First of all, I am adding with this longest suffix one. 128.255. 128. 96.255. 96. So here, first 6 positions are copy, right? 1 2 3 4 5 6. So first 7 positions, 1 0 1 0 0 1 0, then 0.00. You got same thing, remember it. Whatever you have, you got back. That is actually how much value it is? 128 plus 32, 160. It is 164.121, 121.00. So your mapping address is 128.96.164.0. Let's try. You have anywhere? Yeah, 128.96.164.0, but different subnet mask, right? We added with this subnet mask, these 3. Only here you have to check. So when I applied 128, this one dot, this one or this one or this one, it was not mapping. So this is wrong. We should try second mask, correct? So if I apply second mask, what is going to happen? 128.255, 128. Now 96.255, 96. So here if you see 6 ones, then you copy 6 positions, 1 2 3 4 5 6, 00.00.121.00. Yeah, you got again 164. So now when you added with this subnet mask, you got 164. Yes, it is mapping this entry. Yes, perfect, R3. So there is only one entry, we can send it. So finally I got first one as I0, interface 0, second one as R2, third one as R4, fourth one as R3. Now in this one entire thing, trick is nothing but how you apply quickly and this AND operations. Second thing, when multiple subnet masks gives proper entry, that means multiple subnet mask hit success, then we have to take the subnet mask with maximum number of ones. That's it, quite easy. Okay, so based on that you map it. Let's see one more example which is asked in 2015. In the network 200.10.11.144/27. Okay, remember one thing, if they don't mention about class A or class B, so let's assume that it's a classless addressing. Okay, so already you know that classful addressing is obsolete, that means no one is using, but only for exam purpose sometimes we study this classful addressing, remember it. So that's why in the GATE exam, if they mention anything, any problem related to classful addressing, they will mention it clearly. At that time we have to solve with classful addressing, otherwise we have to assume classless addressing. So the fourth octet of the last IP address of the network which can be assigned to a host. So what is the last IP address possible? Already I taught you what is the last IP address, but see the condition that can be assigned to a host. Remember one thing, only two addresses we cannot, that means two patterns we cannot assign to hosts. One is all zeros in the host part, all ones in the host part. So that's why when you are calculating last IP address, so be careful, don't take that last ones thing. Okay, that's supposed to be last IP address, but we can't use for host. Now it's quite easy. If you know that, nothing is there. So last octet he is talking about. First of all, so here I would like to talk about one more thing. Given a CIDR address, that means given some IP address like this. So this is called CIDR notation. So given a CIDR notation, uniquely we can find out what network it is, what is the network ID, and how many addresses we have, everything, correct? So how many addresses we have? 2 to the power of this 32 minus prefix number. So 32 minus 27 is nothing but host bits. So 2 to the power of 5, 32. So there are 32 bits, addresses. So out of 32 addresses, what is the starting address, what is the last address? If you write, then we can easily answer this question. First of all, let's write 200.10.11, because only 5 bits are for host, then only last octet I will expand. How to write 144? 1, that means 128, then 16, 64, 32, 16 is 1, 128 plus 16, 144. Remaining all are zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now identify the host part. Host part is 5 bits, correct? Now, so up to here 10000. Okay. Now the question is, what is the, first of all we'll see what is the network part. What is the network ID? Network ID is nothing but 200.10.11. Copy this network part, but in the host part you write all zeros, then that will become 200.10.11. This is binary pattern. So what is the weight is 128. So write 128. So this will be the network address. Okay, fine. But no one is asking network address. What is the last IP address, correct? Especially which can be assigned to host. Then we write in this part, if you write 5 ones, 1, 2, 3, 4, 5, that's supposed to be last IP address. But this we don't use for host, right? It is for broadcasting. So here this bit we write 0. This is the last, so last but one value I can say. That's quite easy to understand. So if all ones if you write, it will be 255. Sorry, not 255. So we have to find out, but doesn't matter for us. Directly we'll see the value of this one, 128, and this will be, see, 2 power 0, 1, 2, 4, 8, 16. So 128, 16 plus 8, 24, 28, 30, 31. 128 plus 31. 128 plus 31 is what? 129, 159. But I'm sorry, 128 plus 16 plus 8, 24, 28, 30. This bit is not 1, right? 30. 128 plus 30, 158. So finally, the last address which can be assigned is 200.10.11.158. But in the question they are asking only last octet, correct? So 158, especially in the decimal. See, when solving the question, you should be very clear. Sometimes what happens, if you are not focusing, so what you do is you miss so many things. Sometimes once you get the answer also, you get first mistake you do like this, 200.10.11.159 you write, because of your wrong calculation like I did. Second thing, so rather than last octet you write total address. That is one mistake you do, right? So in that way. Third time, maybe you write a binary pattern like this, 1 0, 0 1 1 1 1 1 0, something you write. Again, one more mistake. So that's why if you read the question clearly, then 100% you can answer and you can avoid the mistakes. Okay. Let's see one more example. In a class B network on the internet has a subnet mask of 255.255.248.0. Okay. Then what is the maximum number of hosts per that subnet? Such subnet will have how many hosts? Okay, that is a question. First of all, we'll focus on subnet mask. Okay. Before that, please recall subnet process. In any subnetting process, what happens? So we borrow some bits from host part, correct? So in class B network, remember one thing, if there is no subnetting, so first two octets for network part, other two octets are for host part, correct? But what is this subnet mask? The subnet mask is 255.255.248.0. What it represents? It represents number of ones in the network portion, correct? That means, so this subnet mask, whenever it has ones, that is definitely network portion. If you see that you have 255 here, 255 here, here 248. So 248 means what in the host part? Why you have ones in the subnet mask? That means definitely from here also you are borrowing. Really, class B network doesn't have any subnetworking. That means there is no subnet. If class B network itself is a network, then all that host part should be zeros. Correct? Why? Recall again definition of subnet mask or net mask. Net mask represents, in the net mask, the ones represent network portion blindly. So here ones, there are some ones in the host part also. That means definitely subnetting has been done. That's why we borrowed some bits from net host part. How many bits we borrowed from that host part, if you want to know, then consult the subnet mask. First of all, write subnet mask in binary pattern. It will be like this: 1 2 3 4 5 followed by 3 zeros followed by all zeros. Okay, 1 2 3 4 5 6 7 8. That is the definition of subnet mask, remember. So blindly see the number of ones here. See this portion and this part, 5 bits. That means what? This subnet, whatever we are calling so-called subnet, it has subnet mask like this means what? Definitely this entire thing supposed to be host network portion, remember. Okay. So if any student has doubt here, sir, why like that? That is the definition of subnet mask. Such a way we create the subnet mask to identify network portion. So if this is the network portion, then how many bits we are borrowing from host part? In class B network, actual host part is these two octets. Out of them you are taking 5 bits, correct? Then what is the result remaining host part now? Only this part can be host part in that subnet which you are talking about. Then in that subnet, how many bits are there for host part? 3 in the second octet, 8 in the first octet. 3 plus 8, 11. There are only 11 bits you have for host part. If there is no subnetting, we used to have 16 bits. Now it become 11 bits because you are doing subnetting. Maybe why is the number of hosts has been reduced? Because you are doing subnetting. In the subnetting process, maybe so many subnets you are creating to distribute the addresses to every subnet. Then each subnet should sacrifice some of the addresses. That's why you get less number of bits per host part per each subnet. Okay. Now I don't know anything about other networks, other subnets or anything, but for this particular subnet which we are talking, okay, that has only 11 bits for the host portion. If only 11 bits are there in the host portion, then how many patterns we can generate? 2 to the power of 11 addresses we can generate. Only that we can use. Out of them, 2 are going to be special, right? All zeros is subnetwork ID and all ones is broadcast address in that subnetwork. So that will be 2 power 11 minus 2. It will be 2048 minus 2, which is nothing but 2046. So option C is the right choice. Okay. Now we'll see the next question. A subnetted. Here, a subnetted class B network has the following broadcast address. Okay. 144.16.95.255. Its subnet mask is dash. Okay. Very simple question. A subnetted class B network has the following broadcast address. Remember, this is a broadcast address. Okay. So it has some clue we should understand. Its subnet mask is not given, then what could be the subnet mask? Okay. So why we are not able to uniquely identify subnet mask, we will see. We'll see the options first of all. So one option says that the subnet mask supposed to be 255.255.224.0, second one 240.0, third one is 248.0. We'll try to understand their binary patterns. So this octet is common for everyone, second octet also common, only third octet, in that they have difference, right? Let me write that. Okay, so I am writing a subnet mask which is nothing but 224. Okay, this one. So that octet will have 224 means what? See, first octet, second octet, I am writing here third octet. So in the third octet it will be 1, 224 means 128 plus 64 plus 32 and all zeros, 1, 2, 3, 4, 5. This is 224. Next, 240 means 128 plus 64, 192, 224 plus 16, 4 zeros. 248 means 1, 2, 3, 4, 5 followed by 3 zeros. Okay, so remaining part is same. Now we'll come to the question. They have given broadcast address of a network, that subnet network. Okay, class B is there and it is subnetted already. That's why you got this kind of broadcast address. Let's post-mortem this, this broadcast address 144.16.95.255. So how to identify broadcast part? Did you remember? If you have a subnetwork, in that what is the broadcast address? In the host part you will see all the ones, correct? Now let's start. This is actually class B network. If there is no subnetting, then this should be network part, this should be host part, correct? Sir, we have a question. What is that? Why this host part? Because you said if it is really broadcast address, host part should have all ones, right? Yes, but subnetting has been done. So when subnetting is done, then this entire thing is not host part. Some part of it is network part. We should guess it. So how to guess the network part? We'll see. Up to, sir, here to here can be network part, I think, sir. No, impossible. If this is network part, first 2 bits, okay, which we are borrowing from host part, then if this is the whole network part, then in the host part you can't have 0. Why? This is broadcast address. In the broadcast address, if you say that this entire thing is broadcast address, every bit should be 1. So definitely I can say that network part might be, okay, cannot be only 0 1. So only 0 also not possible. So network part cannot be only 0, network part cannot be 0 1, network part cannot be but network part can be 0 1 0. See why? If you assume network part as 0 1 0, then on that network, see, this can be broadcast address. That's why it's meaningful, right? It makes sense. That means we can assume 3 bits as network part from the host part. Second one, we cannot assume 2 bits as network part, remember it. But can I assume 4 bits as network part? Let's try. If I assume these 4 bits as network part, then still remaining part you see all ones. Still it's a broadcast address. So that is also possible. Now, sir, I can assume like this also. Yes, up to any point you can assume. Example, if you borrow these many bits also, you can form a subnet. Then the remaining bits are representing the broadcast address on that. So for every possibility, this is supposed to be broadcast address. Now we'll come to our question. The question is about, can we say that subnet mask is 3 ones? What is the meaning of subnet mask? This subnet mask says that these 3 bits are network bits. Did you remember? Subnet mask is nothing but whenever there is a 1 that represents network portion. Question number 1. Is this part can be network portion? Let's mark like this. Okay. If this is network portion, this will be host portion. So really this is host portion, then really this is broadcast address. In the host portion every bit should be 1. Yes, correct. Now if 1111 is really subnet mask, let's try that. Anything is possible. If really this is subnet mask, first 4 ones represents host network portion, which is borrowed from the host part. Then remaining should be host for that combination. If really this is host part, then you are seeing all ones, that means it is also possible. Now if I assume 5 ones as subnet mask, that means this as subnet mask, then it says that this is the network portion. Yes, network portion here also possible. 1, 2, 3, 4, 5. The only thing is the remaining part is host part, where you should see all ones. Correct. So for every subnet mask, like whatever you assume, this is going to be broadcast address. That's why I say it could be any one of 255 dot this one or this one or this one. That's it. Okay. Let's solve one more question. A company has a class C network. Fine. And address of 204, 204, 204.0. In class C network, this is official network part, right? 3 octets, and the last octet is host part. Now it wishes to have 3 subnets. Now we have to do subnetting. One with 100 hosts, fine, and two with 50 hosts each. Okay, fine, 50, 50. So which one of the following represents a feasible set of subnet address, subnet mask pairs? So what is happened is the examiner itself created the subnetting everything. We have to identify which one is correct one. So what we do is, of course, we can examine them and we can check it out. Before that, we create our own subnet, because already we have seen so many times, right? But now we use that knowledge and we try to create one kind of subnet, so that you understand by that experience. So you can understand which one is correct one, which one is wrong one. Let's first of all create our own subnet. It may match, it may not match, but you understand the process and you understand the details of subnetting. Okay, so first of all, blindly remember this process. 100, 50, 50. 100 requires 128 addresses, 50 requires 64, 50 requires 64. Already I told you. So whenever some network requires some hosts, that should be 2 to the power. We can give only 2 to the powers, right? Because we are going to take binary bits and we are going to borrow some bits. So if you borrow 3 bits, maybe, so 2 to the power of some x, only that many addresses we can support, because we are playing with binary patterns. That's why, so everything will be in 2 powers. So we can give 128 addresses, though he requires 100. Let him use that remaining 28 in any way. Similarly, if he wants, this subnet wants 50, we give 64, we give 64 for that. Total you see, 128 plus 64, 64 is 128, 128, 128, 256. Original your network has that many addresses or not, we'll see first. This is class C network, 204.204.204.0. This is host part. So host part is only 1 octet. In 1 octet you have 8 bits, then 256 patterns are possible, right? Yes, so it is possible. So now we start subnetting. First of all, take the highest one. So what we do is, we first of all imagine like we are separating 128, 128. In that 128 again 64, 64. First target number 1, this 128. For that, so how many bits? Actually, we are taking 128 addresses from where? Our original 256 addresses. How can we have 256 addresses? What are the patterns? Simple. This is your host part. So this is given by your authority. So you can change it. So all zeros to all ones, 256 patterns. Out of them, so now we are simply dividing logically with 1 bit. Okay. How you see? Let me focus on only that last octet. In the last octet, you have 8 positions, x, 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 correct? Now you have to fix 1 bit. If you fix 1 bit, how many ways you can do that? 2 ways. Example, I am fixing this bit. If you fix 0, then you get 128 patterns. If you fix 1, you get 128 patterns. In that way, so we can separate 256 addresses into 2 blocks. One block of 128 we can give to this one. For that, we have to fix first bit, but it is not compulsory in classical addressing. You can fix any bit, but somehow we have to answer it, right? Let me fix the first bit. If I fix the first bit, and which one, 0 or 1, it's up to you. There is no difference. If so, for network number 1, I am fixing this first position as network bit. That means I am borrowing from the host part. How many bits? 1 bit. So remaining 7 bits are variable. So that 7 bits can generate 128 addresses, which will match our requirement. So this is my network bit from now onwards. Already I have network bits here, here, here. Now from the host also I am getting 1 bit, and that is 0 for me. Now 2 things I should know. One is, what is the network address of such subnet? Second one, what is the subnet mask? Because that is what the question, right? These 2 are important. Example, if this is the way you create, then what will be your network address? I will tell you. Simple. If you want to know the network address, simply in your take your original network, 204.204.204.0, correct? In this one, this is your network bit. It is fixed like 204, 204, 204. This is fixed 0. Remaining all are variable. But if you want to know the network ID, which one from now onwards, let me say this one is host part. Okay. How many bits are there in host part? 7. If all are zeros, then you are going to have a network address. So this is the network address of network 1. So it will be 204, 204, 204, 0. So let me write 0. Okay. Done. Sir, what is the subnet mask? If you want to know the subnet mask, very simple. Subnet mask is nothing but identify the network part. Tell me what is your network part? Sorry, this 8, this 8, sorry, this 8, this 8, this 8, sir. In the last octet, first bit. So all that should be ones. If I make all that ones, then what happens? You get 255, 255, 255 dot. So in the last octet, what you said? First bit should be 1, right? Why 1, sir? To represent. Subnet mask represents, network portion. Is it not your network portion? Yes. Then write 1. When remaining things are host portion or not? Yes. Then you write zeros. That is the way we create subnet mask. Then it will be 255, 255, 255.128. Okay. So in that way, we can generate subnet and subnet mask. Quickly we do for this one also. For 64. For 64, how you do that, sir? Did you remember? We have still 128 addresses. Recall them. What is their pattern? 0 pattern is gone. So it entirely depends on the last octet, correct? In the last octet only we can vary the bits, already I told you. On that, putting first bit as 0 is done. That is taken by this one. So what are the remaining addresses? 1 followed by remaining thing, right? So 1 followed by 7 bits. So now the question is, you will get 128 patterns again. Out of them, 64 we have to give to one network, 64 we have to give one network. Then we recursively solve the problem. Why we have 128 addresses? Because of this host portion. Now this is host portion, I can say effective host portion, right? 1 2 3 4 5 6 7. This is already become network portion. Now out of these 7 bits, one more bit we have to borrow. Why? If I borrow one more bit, by changing it, example, if I take one more bit, and if I keep 0 ones, 1 ones, then with 0 there are 64 addresses, with 1 there are 64 addresses. This 64 addresses we can give to one network. With another pattern like 1, that means in the second bit if I put 1, then it generates again 64 addresses that I can give to second subnet. So now I show only first subnet. Okay, for that, what is the pattern? What is fixed thing here? Already the first bit is 1. Second bit now you are fixing 0. Then remaining 6 bits variable. Now let's tally it. Mr. Host part, how many bits you have? Only 6. That's fine. From now onwards, by this experience, you realize that whenever you want a subnet with 64 systems, then definitely host portion automatically will become 6 bits. So blindly we can remember from now onwards. Network portion will become extra network portion. I am talking about 2 bits. Okay, in that 8. So I can say that how to find out these 2? Very simple. How many bits you had initially? 8 bits for host portion. Then how many addresses we want? Only 64. If you want only 64, then 2 to the power of 6 is 64. Then 6 bits out of that 8 will be going for host. Remaining 2 bits are going to be moved to network portion. Now, so you understand that why this 1 0 is fixed, right? Because 1 is already fixed and 0 now I fixed. Then there is another pattern called 1 1. That is for another subnet. Okay. Now let's do this subnet. So remaining port, first of all, network address. How to find out network address? Very simple. In the host portion you write zeros. Then this octet will become 128 plus 0, 128. That's why such subnet will have address 204 as it is, 204 as it is, 204. Don't touch the network portion. Now in the host portion, your subnet has a binary pattern 10 followed by all zeros. So all zeros represents your network portion. That's why 128. Sir, similarly, please tell the network address of this one. Simple. So this is fixed, right? For the third network, correct, 1 1. then these 6 bits are variable. So that's why 64 addresses this network also is having. What is the network address of such network? Simple. Again keep all host bits zeros. Then you get 128 plus 64, 192. So this will be 192. Remaining thing same. So finally 204, 204, 204, 128, 204, 204, 204, 192. Okay. And first one was 204, 204, 204.0 was the network IDs. Okay. Unfortunately, we'll see anything is matching. 204, 204, 204, 0, 0, 128, 192. 0, 128, 192. Nothing is matching. Okay. So just remember it. Why nothing is matching, I will tell you. Maybe the process you followed may be different from the examiner's process. Already I told you. The borrowing we can take from any of the bits. You have 8 bits, right? Why you borrowed from first bit? Why not from this side? Yes. For the first subnet, you borrowed here. Why not in middle? Already I told you while solving the problems, right? You can borrow from anywhere. That's why various designs are possible. Then whatever the method I explained, like designing, will not help you. That's why don't follow it. Just to get the experience, to understand what is subnet mask for any network and what is the network ID, I just explained you the process. But don't do that. While for practicing purpose you do it, then you get some experience and knowledge with that. With by seeing the network IDs we can answer it. We'll see that. Okay. Now rather than creating the subnets, we directly solve the problem with options. First of all, go to the subnet mask. Recall what is subnet mask. Whenever something is subnet mask, then that subnet mask number of ones represents network portion, number of zeros represents, and the zero portion represents host portion. Remember it. Really, this is one possibility. Just focus on that network portion. Subnet mask. 255, 255, 255. That means this subnet mask claims that such network, okay, has network portion here, network portion here, network portion here, and 192. That means 2 ones in the network portion. Possible, right? So yes, because did you remember we are going to have 128 division, 64, 64 division, correct? So to have 64 division, how many bits we have to borrow? 2 bits. So let's take this one and write in the binary format, 255, 255, 255. That 192 I expand. You get like this 1160 zeros. Okay, 2468. Okay. If really this is subnet mask, this should be network portion. Okay, that's why there are ones. That is 100%. Now this is host portion. So 6 bits in the host portion means yes, it is possible. That means maybe this supposed to be, definitely this has to be subnet of that 64 network. Okay. Now we'll see this one, 255, 255, 255, 128. So don't touch this one, 255, 255 dot 255.128. Then 1 0 0 0, all zeros. Yes. So 1 bit in the host portion is, network portion means what? That means definitely this is host portion, right? Yeah. So this is network portion. Is it possible to have 1 bit in the network portion? Yes. For 128, there should be 1 bit for the network portion in the host portion, correct? Yeah, correct. So possible. Now third one you see 255, same again 255, 255, 255 dot 170 zeros. Here there is a problem. Really this is the split, this is the division. It is supporting a 64 network, correct? That's why there are 2 bits in the network portion. In the last octet, 1 bit, 1 means what? It is having a host portion of 7 bits. That's why 7 zeros. So 128 addresses it is generating. So this is also one of the subnet mask. This represents host portion. In the host portion you have 7 zeros, then that is going to generate 128 addresses. How can you have 128 plus 128 plus 64 addresses? We have, after all this, if last octet can give only 256 addresses, right? Recall, our class C network has only 256 addresses we have. Your subnetting process is now generating 64 addresses here, 128 addresses here, 128 addresses here. Impossible. That's why definitely it's a mistake. Okay. So why it is a mistake in one more level also you can understand. So you are taking two subnets with one network portion. That means, so you are generating 256 addresses here itself. Then another network you are creating, it is impossible. There is a mistake. Okay. So in the high level, we realize that it's a mistake. Now in the same way, by observing the subnet mask, probably we can answer the question. We'll see here 192, 128, 128. Same mistake he did, same pattern. So it is also impossible. Now we'll go to option C. 255, 255, 255, 128. So directly go to the last octet. In the last octet, 1 7 zeros. Yeah. So this supposed to be generating 64 addresses. Yes, possible. 255, 255, 255, 192. So 128, 64, 1, 2, 3, 4, 5, 6. Okay. So second, we write this one also. 1, 1, same thing, right? That's why I'm writing again same time. This is subnet mask, then this is network portion. Yes. If it is network portion, this is host portion. In the host portion, you have 7 zeros. That means what? I'm sorry, here it should generate 128 addresses. Okay. So if this is network portion, this is host portion, how many zeros you have? 6, right? Then 64. Now 1, 2, 3, 4, 5, 6, 6 bits, 64. That means what? 128, 64, 64. Yes. Technically it is possible, right? Now subnet mask is convincing. We'll see network portion. Let me focus on network portion. Remember one thing, the first subnet mask for 128 subnet and second and third subnet masks are fitting for 64 kind of networks. Now we will focus on that network addresses 204, 204, 204, 128. So 128 means I am writing network address 1, 7 zeros, right? 1, 2, 3, 4, 5, 6, 7. Remember it. Second thing, I am writing second one 204, 204, 204, 192. 192 means 128, 64, all 6 zeros. Fine. Third one 204, 204, 204, 224. 224 means 128, 64, 32, 1, 2, 3, 4, 5. This is a pattern. Fine. I can find out a mistake in this one. Why? I will tell you. Here you have 3 ones in the network portion. Okay, fine. So this 1, 2, 3, 4, 5 represents host portion. Recall. Take the subnet mask also. What is this network subnet mask? If you see 255, 255, 255, 192. 192, please write it. 1, 1, 1, 2, 3, 4, 5, 6. Right? First of all, by seeing the subnet mask, you can identify the network portion. What is the network portion? Here, here, here. This is network portion. Okay, fine. And why here there is a 1? Let me ask. Here 1, you are having 1 means what? This is not network address. Recall network address. Network address is nothing but it is a binary pattern where in the host portion all zeros we have to write. So you agree that this is host portion. That means this is host portion. In the host portion, why we wrote 1? That means this is not a network address. The correct network address for this subnet mask is 1, 1, all zeros. So the right network address is 204, 204, 204, this one 192, but not 224. This is problem. Okay. So finally option C is wrong. Now we'll see this one 204, 204, 204, 128. Why this is correct we will see. Okay. If and all if it is correct. Now see the option D. In option D, let's say is actually correct. Why it is correct? Because other 3 options are wrong. Now, but somehow we prove that this is correct. How you see? This is subnet mask, right? 255, 255, 255, 128. And why this subnet mask has 2 1s here? Definitely. So there are 2 borrow bits here. That's why this 2 corresponds to 64, 64. And there is only 1 1 in the last octet means what? This is representing 128 subnet, right? So first of all, we begin with this one. And you see 128 means what? Definitely you can understand. See 255, 255, 255. This subnet mask is going to give the position where you are borrowing. Right? Hit 1, 7, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7. Right? So we know that the 1 represents network portion. This is network portion means what? You borrowed from most significant bit, right? Remember it. So corresponding network ID, whether matches or not, we'll see. Corresponding network ID, first 3 octets will be definitely network portion, which is given by authority, that should be fixed. Now in the remaining 8 bits, why we got 128? Only one bit we have to borrow, correct? So, and that borrow bit is definitely, I'm writing 255 here, okay. So that 8 bits, if you see, anything first of all, 1, 2, 3, 4, 5, 6, 7, 8, okay. This subnet mask says that first bit is, network bit, then it can be 0 or 1, but it's up to you. Already I told you. Why he got 128? That means he might have used 1 here. Okay, fine. So finally, one subnet has, 204, 204, 204 and 128. Perfect. It is matching. If really he uses 1 here, that other subnets should use this bit as 0. Then only the addresses can be separated, right? Okay, fine. 204.204.204 dot. The remaining patterns we have is 0 followed by 7x. Okay. That's why I explained initially subnet process, so that easily you can catch up. Now 7 ones. How many networks we need? 2 more, right? But 64. How many addresses we have? 128, because 7 host bits. So one more bit to be borrowed. So which bit? We ask subnet masks. So here 192 indicates what? Recall. So this 192 means what? Here one I am writing subnet mask for one of the subnet. Okay, 255. Why 192? First of all, write the pattern of 192. 1, 2, 3, 4, 5, 6, 7, 8. Why 2 ones here? Because it's network portion. Finally, I realized that this is the network portion. Find this bit. Okay. In this network portion, what to write? Anything you should write. If you write 0, that will form one set of patterns. 64 patterns we can give to one network. If you write 0, 1, that's supposed to be the another network. So finally I got 2 networks which are given by how examiner done, we exactly doing in the same way. So that will be 204 dot 00 followed by anything, 01 followed by anything. Now you want to know the network IDs? Simple. This will be the host part, 6 bits. Write all zeros. Here also write all zeros. You get the network ID. So 204, 0, 204, this one. 01 means this weightage is 64. So that's why 204, 64, 204, 0. So option is perfectly right. Understand? So this is a way with our common sense and sometimes experience we can solve all the questions. You need practice. Remember, if you practice and if you practice more, you understand so many details. Okay. So faculties teach only 80%. Remaining 20% should come from your experience. Okay. Let's solve one more question. Host X has IP address 192.168.1.97 and is connected through two routers R1 and R2 to another host Y with IP address 192.168.1.80. Let's mention that. So there is a system called Y. Its IP address is 192.168.1.80. Yes, I understood that. Now X has IP address 192.168.1.97. Fine. Now in the statement it is given that this system X is connected to two routers R1 and R2. That means X is connected through these routers R1 and R2 to Y. That means I can say that all the messages or all the packets of X should go from either R1 or R2. Doesn't matter. Anywhere it can go. Remember it. So that's why he mentioned clearly that X is connected through two routers R1 and R2 to another host Y. Okay. With IP address is given. Now R1's IP addresses are given. There are two IP addresses for R1. Just remember them. One is 192.168.1.135. Second one 192.168.1.110. Fine. Similarly, R2 has IP address 192.168.1.67 and 192.168.1.155. Fine. The net mask used in the network is, this is very important, network mask. So what is that net mask? 255, 255, 255, 224. Count the number of ones. 8, 8, 8, here 3. So 27 bits for network mask. That means what? So easily we can understand that network portion is first octet second octet completely, third octet also completely, and in the fourth octet, first 3 bits. Whether it is classful address or classless now doesn't matter for us. We have network portion. What is that? This entire thing. Okay. So the portion is 27 bits, right? So these 7 ones, sorry, 8 ones, here 8 1 16 and 24, and here it would be 3 ones, right? Followed by 5 zeros. This is the network mask. So what I want to tell you is the number of bits are going to indicate the network part. Remember it. That is very important. Now the question, which IP address should X configure? It's gateway. What is gateway, sir? Very simple. Gateway is nothing but in a network. Example, let's say X belongs to some network. So we know that. So X is going to send a packet to some other computer or any other device, and that assume that let's say that device in another network. Example here Y. So whenever X is sending one packet from X here to here, so eventually that packet will come to one router, right? After that it will go to another router in that way. I don't know how many routers it will pass, but first time what is the router from which it is going out of the network? That is called gateway. Gateway is nothing but it's a device from which a packet of that network is going out. It's, I can say, exit point. Like every house is having doors, right? Exit doors. So from that we are going out. Similarly for your network also, so there will be some interface, I can say, maybe generally it is router. So through that router, let's say your packets are going out, such routers are called gateways. Okay, so now you tell me which one I can use as gateway. So what is the property of gateway? Gateway should be a device, otherwise interface, whatever it is. From that point, data, otherwise packet of that network should go out. Remember it. That is enough to solve this problem. So now the question, if you see how to configure it, that means example, let's say you are configuring the gateway. Okay. So what is the IP address you use for that? Since it is going to be exit point of this network, first of all that that exit point should be part of the network, correct or not? Example, let's say there is one device which is not part of the network, then how it will be gateway? Example, sir, my packet is going first from this point, sir, after that it is going, but before that it is crossing your network, right? If this is not part of your network, then that cannot be gateway. Gateway should be part of your network, because according to definition of gateway, gateway is a point of your network from which your packets are going out. Okay, just remember it. So you tell me what could be the address of that gateway. We will see. You can keep anything, but first of all let me draw the picture. This is, let's say, gateway. It should be part of your network. That is enough to solve this problem. So they have given the IP addresses. So tell me any IP address we can use for gateway, but that should be part of this network. Sir, what is this network? Which network you are talking about? A network where your X is part of it. Okay. So what is the IP address of X? 192.168.1.97. So identify the network of this IP address. Already I told you so many times how to find out the network address. We have our friend subnet mask. Use that subnet mask. That subnet mask is going to give you the network portion. Okay, in this one, what is the network portion? This is one of the IP address of some network. In that network portion we'll see. So 192. So let's write 192 as it is, because your network portion is this plus this plus this plus 3 ones in the last octet. So 192.168.1, everything is same. So in this last octet only 3 bits is network portion. Okay, so let's write 97 in binary pattern. So sir, why didn't you write this one as binary? Because entire all the bits of this is going to be network portion, so it will come. And one more thing, from now onwards, one more thing you remember, if you do AND of this with subnet mask or network mask, you get what? Network ID directly, right? You can do that also. Then let me do that directly. Okay, anything will work. So I take 192.168.1.97 and I apply 255.255.255.224. If you do ANDing, then you get network address, and the network address will be 192.168.1.96. Remember it. Okay. Now, if one of them, if you configure as gateway, then that IP address should be part of this network. How do you understand that? How do you know that this is part of this network? Simple. Take this address and AND with this IP address, sorry, subnet mask. If you AND this with this, if you get this network address, then I can say that address also part of this network. Now gateway has an important property here that it should be part of the network. Surprisingly, what happens? Only this is part of your network. You see. Why this is part of your network? If you want to know, without this ANDing operation also I can tell you. So what is your network part? Did you remember? First of all, you see the IP address 192.168.1.97, right? In that we'll see the network pattern 192 as it is. This is network portion 16 plus 8 here, network portion. Now in this one, 3 bits is the only part which is network portion. Write binary pattern for that. So 128 bit is 0, 64 bit is 1, 32 is 1, and after that directly 0, 0, 0, 0, 0, 1 I think. Okay, 1, 2, 3, 4, 5, 6, 7. So it is 1. So this is your IP address. What is the network portion? 27 bits up to here. Remember it. Okay. Now take the option A. Why it is wrong, I will tell you. Write its IP address, you will understand. 192.168.1.67. If you write 67, its binary pattern will be 128 bit 0, 64 bit 1, and directly 67. So it will be 00111. Okay, so this is 67. What I want to tell you is, see the network portion of your IP address 011. What is the network portion here? 010. Are they same? No. Their network portion is different. These two belong to different networks. That means this cannot be gateway. That's it. So it looks very lengthy, but question is very simple. Finally, your gateway's IP address should be, should belongs to your network. That's it. And they use a very big name like gateway. But gateway is nothing but a device which is just exit point of your network. That's why it should be part of your network. If you know that, so nothing is there. And one more thing. So here, if you want to know the network address of your IP address, very simple. Take the network portion. This is network portion. In the remaining bits, you write zeros. So you are going to get network address. So this will be 192.168.1.96. This is 64. This is 32. 96. If you do AND with your subnet mask also, you get same thing. Understand? Now there are two methods. One is directly see the network portion of every address. If that network portion matches with your IP address network portion, then that is the answer. Second thing, second thing also concept is same but in different way. Take your IP address and with this one, you get your network address. Now take all the options and AND with that subnet mask or net mask. If same network address you get for both of them, for your IP address, initial IP address, X IP address, and answers IP address, if they match, they belongs to same network, so that can be configured as gateway. Very simple. Okay.